Hello, welcome to Pre-Calculus. For this lesson, make sure that you're actually doing all these problems, not just copying it from somewhere, because this is from everything you've learned so far in this chapter. I would consider this pre-calculus, maybe to calculus level. If you take it a step at a time, it's actually not that bad. Here we're going to go ahead and use DeMovivre's theorem. So according to this, we have if z is equal to that polar form. So we have the complex and we convert it to polar form, which you should have done on your previous examples there. You'll have z equals r times the cosine theta plus the sine theta. Remember, r is the modulus and theta is considered the argument there. So now then you have, so let's say we have an exponent, so z to the second power. So if it's z squared, that means every factor here you're going to square. So you're going to factor the modulus, you're going to factor the arguments of each one. So if it's radians over 3 times 5, because that was the exponent, it's 5 times radians over 3, which is 5 radians over 3. So you're multiplying the argument there. We're going to do example 7. You have a couple of these for your homework. So according to this here, we have 1/2 plus 1/2 I to the 10th power. The first thing we have to do to solve it out, before we use DeMovivre's theorem, we have to put it in terms of this, which is a polar form. So now, let's go ahead and find our r and our argument. So remember, this is a and b. To find our modulus, all we do is take the square root of a and square root of b and then combine it. So here I have 1/2 and 1/2. That is equal to 1/4 plus 1/4. And that is equal to 2/4. Remember, when you're taking the square root of a number, you take the square root of the numerator and denominator. So the square root of radical 2 is just radical 2. The square root of 4 is just simply 2 because it's a square. So we found our radius, so that's good there. Now we have to find our argument here. So remember, our argument is the tangent of b divided by a. And that goes back to here. So before we start dealing with this, we just have to put in polar form. So that would be the tangent of the argument is equal to 1/2 divided by 1/2. If you remember, you can multiply the bottom by reciprocal, the top and bottom, but if you're multiplying or dividing by the same number, you're going to end up with a positive 1. So here for the tangent is equal to 1. This is where this chart is going to be very, very handy for you. So instead of doing it in your calculator, because you're going to have decimals, I don't want decimals on all of them, only a very few. Here is where it's going to help you out. So tangent of 1, remember we graphed it. We always graph it, but it's very important, especially example A. I was stuck on a problem. I was wondering why it was a certain problem, because I didn't graph it and I didn't see where the degrees were. According to this, the polar form is in the first quadrant. So I'm looking in the first quadrant. If I divide y divided by x, I look over here, and the only one that will give me 1 is over here, is radians over 4. So that means my argument is radians over 4. So my whole equation is z is equal to r, which is radical 2/2, times the cosine of radians over 4 plus I sine radians over 4. Don't forget the I after the sine, because remember, it's polar form. So now this is my polar coordinate. According to this, it's to the 10th power, so it's like as if we were adding a 10 on top. So if we were adding a 10 on top, z to the 10th power, I would have to apply the 10th power to my modulus and apply my 10th power to my argument there. So I have 10 here, and then plus I sine of 10 times radians over 4. And then from this point, we just simplify. Here we use basic algebra to simplify. Let's look at this side here. So remember, when you're square rooting the top or bottom, you have to make sure for the top one, you're square rooting the top as well, or you're applying the exponent there. So remember, radical 2 to the 10th power. Remember, when you're doing radicals, it's always the exponent divided by the root. So think of 10, the exponent divided by the root, and the root is 2. So that's why they have 2 to the 5th power times 10, or times 2 to the 10th power. That's why they have the 5, because they divided the exponent divided by the root. Now, here I'll have the cosine of 10 radians over 4. I just get 10 radians over 4 plus I sine 4 because I'm multiplying it into my argument. I simplify it even further. So the numerator I get, let me just see what I got here. I got 32 over 2 to the 10th power is 1024. So I get this. And then whenever I look at these type of radians, I always think of fractions. I think of 10 over 4. If I were to simplify 10 over 4, I get 5 radians over 2. So I get 5 over 2 and just add the radians in the end. So again, just think of them as fractions. So for this one, I'm going step by step because we're applying this type of method to the next one here. So now I can simplify even further. So 32 over 1024 is actually equal to 1 over 32. And then I have the cosine of 5 radians over 2. If I actually find this in my graph, which it should be in your graph, 5 radians over 2. Oh, 5 radians over 2 is actually equal to 300 or 420. Something around there. Which means that if you were to subtract 360, so you can keep it within the circle, it's actually, the co-terminal angle would actually be 90 degrees. So again, just multiply 5 times 180 divided by 2. You're going to end up with something greater than 9 degrees. Divided or subtracted by 360, you end up with 90. So here, according to this, my cosine of that, remember it's my x, is considered 0. For my sine, it's considered 1. I'm just going to put an I here. So 1i. You have to include the I does not disappear here. So it was 0, 1 for the coordinate. So I have here 0, or 0 plus I, because always adding here. So now the last step, and that's what we're going to do for all of them, you're going to multiply it out. So when you multiply it out, 1 over 32 times 0 is just 0. And then 1 over 32 times I is 1 over 32i. So take it one step at a time. Again, if you need a refresh, there are more examples you can do in the book, but you need to know this part down before you do this one and the next example. Next one. So it gets a little bit more complicated. I'm going to make it pretty big so I can show you. The book has 6 different ways. So here it says, find the sixth root. So here now we're identifying everything based on their roots. Z is equal to negative 64. So if we look up here, this is the nth root equation. So let's say we have our polar form, so from our complex number. Here it says WK, meaning the numbers. So we have 6 here. They want us to find from 0, 1, 2, 3, 4, and 5. Those type of numbers, but we want to take it to the 6th root. So there's sixth root, meaning we're doing this 6 times. So here, W of 0, W of 1, that's where your K is, a number of numbers that they want you to find. So now it says R to the 1 over n power. So the n, 1 over n, remember just like how we were dividing over here, we're dividing by the root. You're dividing by the root that they're asking for. In this case, from this example, is the 6th root. Here is a cosine, and I'll show you how to do these. You're basically adding 2 radians, and you're dividing by your root for each one, but I'll show you step by step. According to this, if I were you, I would just stick with finding the polar form first. So exactly what we did over here, we found the polar form first, and then we went and apply the theorem up there. So here, I'm going to find my R. I have to find my argument. And so for this, it's going to be the square root of negative 64 squared plus 0 squared, that's just going to be 0. So if I do this, this is going to give me positive a number, and it's just going to cancel out and give me a positive 64 there. Because if I do negative 64 squared, it's going to give me a positive answer. And if I take the square root of that, it's going to give me back to positive 64. So I just cancel out here, but just think about you're squaring and then you're applying the roots. So therefore, it's going to end up positive anyways. So my modulus is 64. And now I have to go ahead and find my radians here. So remember, keep in mind, it's in this format, negative 64 plus 0i. Just because it's a number doesn't mean it's in polar form. It just means that the I, it's imaginary, but there's a coefficient of 0 in front. If I were to graph this, first of all, it'll be negative number. Remember, it's negative a and a, positive imaginary and negative imaginary. So negative 64 will be over here. So if I graph it, it'll be somewhere between the 2nd and the 3rd quadrant. So now let's go ahead and find our tangent. So remember, it's a tangent of b divided by a. So that would be the tangent of b, which is 0, divided by 64, or negative 64. So we're just looking at this before we went ahead and found a modulus. So it's b divided by a, and anything divided by 0 is 0. So here, if the 0 is in the denominator, that's when it would be unidentified. Dang, why do I keep doing that? Just a 0. So if it's on top, it just equals 0. Here we have to find where tangent is equal to 0, and there's only two possibilities in this whole chart, and that's why I said it's very important to graph it. So here, the only way you can get 0 if you were to divide it is if you were focusing on these 4 quadrants over here. So you have this one, this one, this one, this one. So actually you can't use the top or bottom, because if you divide, you're dividing by 0, so that's unidentified. But here, if you divide 0 divided by 1, you get 0. If you divide 0 divided by -1, you also get 0. But when I graphed it, and that's why it's important, when I graphed it, it's between the second and third quadrant. Here you have two options. You have radians and 2 radians, but because I graphed it on this side, that's where my polar coordinate was, I have to follow this one. And the only one that will give me 0 for tangent is radians. Now I write my polar form. So now my polar form is r, which is 64. And that is the cosine of radians plus the sine of radians. I sine radians, don't forget that. And that is my polar form. From this point here, we go ahead and take the nth root. What that means, we're applying the root. And according to this, I'm going to go ahead and put it here. We're finding what our k is. We're finding when the 0, the first number, the second one, the third, the fourth, the fifth. It says 6, but if you're counting all of these, 1, 2, 3, 4, 5, 6, that is considered 6. And then the n is considered the nth root, and it says the 6th root, so that's where it says, if it says cubic or square, that means 2 or 3. Now let's go ahead and apply it. So according to this equation, I'm going to have w sub 0, that's our first one. So we're using each of these, or I'm finding these. So on your book, they have it written down 6 times. I'm going to write it 6 times, but I'm using the same equation just to save space. So I'm going to make it a little bigger. So I'm starting with 0. So according to this, it's 64, so it's your modulus, divided by 1 over the root. The root is considered 6. Now, we have here the cosine, and what I'm going to do here, it's slightly different from the book, but I've looked at other resources, it's a lot easier to look at this, is focus on your measurement, so your radians, and everything is dividing into the nth root, so the n is still 6, so it's your original degree divided by 6, plus, according to this, is 2k radians. So it's like 2 radians, which is a 360, times your k. And your k in this case will be the number that you're starting with. It's this number right here, which is 0. And again, it's all over 6. So I just separated this into 2 fractions instead of making it just 1 fraction. So now, from this point here, do the same thing with sine. Remember, the sine and cosine, they have the same work here. So it's, again, the same one. It's your regular thing divided by the root, plus your 2 radians times the k, which I'm starting with 6, divided by the root. According to this, we go ahead and simplify from here. So 1/6 of 64, so if you do that in your calculator, you end up with 2. So this is a 2. That means from now on, when you're working the rest of them, you're going to end up with a 2 here. 2 times, and for this, I kind of skipped a step. So radians over 6 plus 2 radians over 6. If I look at it, I'm not going to focus on the radians. 1 over 6 plus 2 times 0 divided by 6. 2 times 0 is 0. 0 divided by 6 is 0. So technically, this will all cancel out, and I'll just end up with my radians over 6. And it's the same exact work with the sine. So now I have this equation here. So remember, I just simplify here. Just think of it as fractions. Add the radians on top in the very end. Here, I'm going to go ahead and simplify it, and now I can simplify it even further. If I have my graph, all of these coordinates should be on your graph. So here, radians over 6 is considered 30 degrees, so I'm going to follow this. So the cosine of radians over 6 is radical 3 over 2. So now I'm going to do 2 times the cosine radians over 6 is radical 3 over 2. Again, look at your chart, and you have it here. Plus, the sine of radians over 6, remember that's a y-coordinate, I got 1/2, and I have to include my I there because it's it's complex numbers. And when I simplify that, I have this here. You multiply it out. 2 times radians 3 over 2, the denominators will cancel out, and you're left with a radians over, or radical 3. And And then 2 times 1/2, half of 2 is just 1. You'll just end up with 1i or just I, and that will be your answer. So that's your first one. So looking at this, you could pause it. You can maybe see how I got a little bit more because we're going to do everything else the same. So now let's go ahead and find the second one. So I'm going to go ahead and erase all this. And now I'm going to find the first one. So I did 0. I'm going to go ahead and do 1. So the only thing it will change from this whole equation, I'm going to use the same exact equation. So if you saw my work, I wrote it down so many times right here. I showed all of my work. So now, same equation, but now we're changing it. We're trying to find the second place one, the second number. So 1. So everything stays the same. The only number that you replace is the k's over here. The roots stays the same. They're not going to change. Now let's go ahead and find the first one. So 64 to the 1/6 power, again, is 2. The cosine, now I look at it this way. So I think of radians over 6. 2 times 1 is 2, and I got it over 6, so I think of 2 over 6. Think of 1 over 6 plus 2 over 6. That would actually simplify to 1/2. And when I have 1/2, I just add the radians over. So again, just think of it as fractions. 1/6 plus 2 over 6. I get 3 over 6, which is equal to 1/2, and just add the radians in the very end. So now, it's the same thing with the sign. And now I have this. Next step, we have our graph. Radians over 2 is considered 90 degrees. We use the coordinates that we have here. So now, 2 times the cosine of radians over 2, that's our x, that's considered 0, plus the sine of radians over 2, that's our y, that's considered 1, and it's just 1, but we still have to consider the I there. Now, you go ahead and multiply it out. When I do, I end up with just 2i. And that's my next answer. So my answer is this. It's not showing this work right here. So make sure you show it all the way out. Third one. So now I go ahead and find the next one, which is 2. So I'm going to erase this, I'm going to erase this, and I'm going to erase this. So finding the second one, consider these our third one. So that means in place of the k, I'm just going to replace a number. Everything else stays the same. Now, if I go ahead and solve it out, I know that the 64 to the 1/6 power is 2. So now I have 1 over 6 plus 2 times 2 over 6. So that will be 4 over 6. So 1 over 6 plus 4 over 6 is equal to 5 over 6. So I'll have the cosine of 5 radians over 6 plus I sine 5 radians over 6. And then you go ahead and simplify. So 5 radians over 6 is considered 150 degrees. Again, you focus on the coordinates there. So the cosine of 5 radians over 6 is negative radical 3 over 2. And then plus the sine of 5 radians over 6 is 1/2. And just include the I in the very end. I always go second. It's always A plus BI. So you go ahead and simplify it. You go factor it out. So then you get, this cancels out, you get negative radical 3. And then 2 times 1/2 is just plus I. But this turns into a negative. And we can keep on going. And the last example I'll show you in the next video. So we did 2. So we're going to go ahead and do 3. So again, we're going to place the number here. We're going to place the number here, where k was in our original equation. So now we have 3, 3, 3. So now let's go ahead and simplify. We have 2 times the cosine of 2 times 3 is 6. 6 over 6 is 1. So think of 1/6 plus 1. And you end up with 7 radians over 6. So 7 over 6, but then add the radians in the end. And then it's the same thing with the sine. So you end up with this. 7 radians over 6 is considered 210 degrees. So 210 degrees, again, you're focusing on the coordinate there. So the coordinate for cosine of 7 radians over 6 is negative radical 3 over 2 plus, and the sine is considered negative 1/2 I. And after that, simplify even more. 2 times negative radical 3 over 2. Remember, the denominators cancel out, so you end up with negative radical 3. And then 2 of 1/2 is I, but the negative makes a negative, and you have that number there. And last one before I go ahead and finish up here. So here, I'm going to go ahead and erase this here. We have 4, and we have 5 to go. So it does take a lot, but I'm not going to require all of them for one example. Or a couple of the problems, I'm going to have you find the first, the second, the third, and the fourth, and fifth one. And it's just one per problem there. So again, simplify even more. So now we're finding the fourth one. So that means 2 times 4, we get 8, 8 over 6. So we have 1 over 6 plus 8 over 6. We have 9 over 6, but can be simplified to radians over 6. So now, I'm going to find the cosine of radians over 6. Sorry, 3 radians over 2. I sine 3 radians over 2. So 9 over 6 simplifies to 3 over 2. Add the radians on top. And then after that, convert it to coordinate form. So the cosine of 3 radians over 2, that should be 270 degrees. Find the coordinate on your grid. And you end up with 0 plus negative 1. So I'm just going to put negative I. So you don't even need a plus sign, it's just 0 minus I. But I just like to have it there to show me. You go ahead and distribute. So this cancels out and you get 2 times negative I will give you negative 2I. And then the last one before we go ahead and finish up for this first part. And make sure you see the second part of the video. It shows you more examples. The last one. So my last one is the fifth one because they want to find all 6. So again, replacing 5 here, replacing 5 here. So this all stays the same. And now you multiply it out. 164 to the 1/6 power is 2. The cosine of 2 times 5 is 10. 10 over 6 plus 1 over 6. I end up with 11 over 6, which is in your coordinate. I think it's 300 and something. 315? Yeah, 315 degrees. So you look for the coordinates there, and the coordinates for this would be the cosine of 315 degrees, I get right, equal 3 over 2, plus, and the sine of 11 radians over 6 is negative 1/2. Go ahead and multiply it out. This will be equal to positive radians 3, and then negative 1/2 times 2 is just negative I, and then you have this. On your paper, on this book here, it shows you the circle. If you were to graph each of those coordinates there, you end up with the circle. If you see that right there in the corner, that's where all those coordinates came from, and that's where they want you to understand. They came from somewhere. All right, let's do part 2 in the next video.